Next is we will start from some articles. First is prove that A cross B intersection P cross Q. This is A cross B intersection P cross Q is equals to A intersection P cross B intersection Q. We are to prove this. So take left hand side. Left hand side is A cross B intersection P cross Q. Okay. I already told you whenever we have to find the equality, we will take any element on left hand side and we will prove that this element belongs to right hand side. Similarly, again we will take the element on right hand side and we will prove that element belongs to left hand side. From these two, we can find the equality. So first of all, we are going to take left hand side and we will take some element in this left hand side. Now see, we are having cross product. So whenever we will be having cross product in any term, we will take ordered pair. Let ordered pair xy belongs to A cross B intersection P cross Q. Okay? Implies that now this element belongs to intersection of these two sets. This is one set, this is second set. Now this element belongs to intersection of these two sets. Implies that I hope that you all remember the definition of intersection. Implies that xy belongs to A cross B and xy belongs to P cross Q. Okay? Intersection means the element will belongs to this set as well as the element will belongs to second set. Now, the definition of Cartesian product of two sets, if we are having xy belongs to A cross B, what does this imply? That x belongs to A and y belongs to B. Okay? This and will remain as it is. Similarly, now xy belongs to P cross Q. Xy belongs to P cross Q means x belongs to P and y belongs to Q. Okay? Now see right hand side. We want that the element belongs to A intersection P. Combine the terms accordingly. X belongs to A and x belongs to P. X A may be here, x P may be here. And everywhere is and. We can write the terms according to our conditions. Okay? We did associative law last time. Associative law means A intersection B intersection C is equals to A intersection B intersection C. You can change your sets according to your condition. Right? So, x belongs to A and x belongs to P. And similarly, y is in B and y is in Q. We can write y belongs to B and y belongs to Q. Okay? Implies that now x belongs to A and x belongs to P. We can write in symbolic form that x belongs to A intersection P. And ka matlab intersection. We can write x belongs to A and x belongs to P means x belongs to A intersection P. In the case of and, we are using intersection. Similarly, and y belongs to B and y belongs to Q means y belongs to B intersection Q. Okay? Implies that. Now, we did the definition of Cartesian product of two sets. Cartesian product says that xy belongs to A cross B, then x belongs to A and y belongs to B. हमने यही definition पढ़ी कि if x belongs to A, xy belongs to A cross B, then it means that x belongs to A and y belongs to B. First element will belong to first set and second element will belong to second set. Okay? Now we are with this condition. X belongs to A and y belongs to B. We can write this condition in place of this. If we are having xy belongs to A cross B, we can write x belongs to A and y belongs to B. Similarly, if we are having x belongs to A and y belongs to B, we can write this. that XY, ordered pair XY belongs to A cross B. Now we are with this condition. Okay, X belongs to A intersection B. This X compare with this X. This A intersection P compare with A. This Y and this B intersection Q. Okay. Now compare this term with this. We are to use this. We can write X, Y from first set and from second set. किसको belong करेंगे? It will belongs to A and की जगह पे cross. It will belongs to A cross B. So we can write this X and this Y. X comma Y ordered pair XY belongs to this set, that is A intersection P cross B intersection Q. So which is equals to right hand side यही थी. This is A intersection P cross B intersection Q. So we are having A cross B intersection P cross Q is a subset of A intersection P cross B intersection Q. Similarly, we can write A intersection P cross B intersection Q is a subset of A cross B intersection P cross Q. This is equation number 1. This is equation number 2. From equation number 1 and 2, from this equation and this equation, we will find the equality. That is A cross P intersection P cross Q is equals to A intersection P cross B intersection Q. And then you will write from 1 and 2, we will come to this term. Fine. So this is how we can prove the articles. Just take left hand side and product. Next is prove that A cross B intersection C is equals to A cross B intersection A cross C. Prove this. Again, we are to prove this equality. Before proving this equality, we will prove that left hand side is a subset of right hand side and the right hand side is a subset of left hand side. So if we prove these two things, we can prove the equality. So first of all, take left hand side. Left hand side is A cross B intersection C. Again, we are having this Cartesian product in the equation. So we will take let ordered pair XY belongs to A cross B intersection C. Okay, जब भी whenever there is Cartesian product, we are to take this ordered pair. But if you will take like this A cross B intersection C, after that you goes on proving this, the whole question will become wrong. Okay, whenever the Cartesian product is there, you have to take this ordered pair. Ordered pair XY belongs to A cross B intersection C. Now, by the definition of ordered pair, implies that X belongs to A, first element belongs to first set, and second element will belongs to second set. And here the second set is B intersection C. This is one set. Okay? The first element will belongs to the first set and second element will belongs to the second set. The second set, that is after the cross sign. First set means before the cross sign. Okay? So X belongs to A and Y belongs to B intersection C implies that X belongs to A and Y belongs to B. Now the definition of intersection implies that Y belongs to C. Y will belongs to B as well as C. After that, now see what the right hand side is. We need A and B, A and C. So simply open the brackets. X belongs to A and Y belongs to B. एक बार इसको इसके साथ मल्टीप्लाई कर दिया. After that, again X belongs to A and Y belongs to C. Implies that now again we are to apply the definition of Cartesian product. We have X belongs to A and Y belongs to B. After merging it, we can say that X belongs to XY belongs to A cross B. ठीक है? you know the definition of Cartesian product. If we have ordered pair xy belongs to A cross B, implies that x belongs to A and y belongs to B. Okay. Now again we are converting it into the definition. Similarly, y belongs to A and y belongs to C means ordered pair xy belongs to A cross C. Now ordered pair xy is in A cross B as well as ordered pair xy is in A cross C. So by the definition of and, we can say that ordered pair xy belongs to A cross B. In the place of and, we are using intersection. It will be A cross C. So right hand side यही थी हमारे पास. This is right hand side. So it means that A cross B intersection C is a subset. We have taken the element in left hand side and we have proved that this element belongs to right hand side. So A cross B intersection C is a subset of A cross B intersection A cross C. Similarly, we can prove that A cross B intersection A cross C is a subset of A cross B intersection C. Okay. Let it be equation number 1. Let it be equation number 2. From 1 and 2, what we can say that A cross B intersection C equals to A cross B intersection A cross C. Fine. After that, next is prove that. Next is you can take the screenshots if you are reading the notes. Next question is prove that if A is a subset of B, if A is a subset of B, then A cross C is a subset of A cross C is a subset of B cross C. If A is a subset of B, then A cross C is a subset of B cross C. I already told you, whenever we want to prove the article, first of all, write proof and then write given. Whatever the condition is given, you have to write it. Given that A is a subset of B, after that, to prove what we want to prove, that is A cross C is a subset of B cross C. Now, whatever we want to prove, always take the element on left hand side and prove that this element belongs to right hand side. So now the element is A cross C. It means that we are to take ordered pair xy belongs to A cross C. Okay? By the definition of Cartesian product, x belongs to A and y belongs to C. Okay? Implies that now x belongs to A, but we are given that A is a subset of B. It means that x belongs to B and y belongs to C. Given hai hame ye, it is given that A is a subset of B. Implies that now again we are to convert this in symbolic form. We are having x belongs to B and y belongs to C. It means that ordered pair x y belongs to B cross C. We had taken the element in left hand side and we have proved that this element belongs to right hand side. Therefore, from 1 and 2, we are having A cross C is a subset of B cross C. Next question is, if A is equals to next question is, if A is equals to 1, 2, 1, 3, and it is fun. If A is equals to this, then determine the following sets. Number 1, A minus 1, number 2, A minus 5, number 3, A minus 5, and number 4, you have to find the value of A minus 1. So you have to find all these values. Last time we had did the definition of difference of two sets. Difference of two sets means A minus B. If X belongs to A minus B, it means that X belongs to A and X does not belongs to B. X will be present in A and X will not be in B. This definition we will apply here, A minus 1. So what does A minus 1 means? We are having the set A as 1, 2, 1, 3 and 5. This is the set A. This set A is having 4 elements, that is 1, 2, 1, 3 and 5. First of all, we want to find the value of A minus 1. A minus 1 will be all the elements of set A which are not present in set B. This is set 1 and this is set 2. So A minus 1, we are to take the elements of A which are not present in B. Now this one and this one. This is also set. Okay. So value will be 2, 1, 3 and 5. Second, A minus 5. Now this 5 is nothing. This is A minus 5. We are to subtract nothing from the set. It will be again 1, 2, 1, 3 and 5. This 5 will remain same. A minus 5. Now we are to delete this set 5. So it will be 1, 2 and 1, 3. Now this 5 will not be here. At the end, A minus 1, 2, A minus 1, 2 means 1, 3, 5. Okay, no. So, is there any difference or relationship between these 4 identities? There is difference as well as relationship. See, phi means empty. This is empty. Or you can say empty set. Okay. We had done A minus 5. A minus 5 means this set contains nothing. खाली है ये set. इसके अंदर कुछ भी नहीं है. This 5 means a set. It can be singleton set. Singleton set means a set having a unique element. Set having unique element. And that unique element is 5. But there is an element. No doubt that element is 5, but there is an element. In this case, if we want to find the cardinality of this, it will be 0. कुछ भी नहीं है, लेकिन इसमें तो है ना. There is one element, and name of that element is 5. ठीक है. After that, this and this is same. Set में either you write like this or you write like this. This is one and the same thing. अकेला phi लिख दो, या you can write only curly brackets. This is one and the same thing. But if you write phi in some set in the curly brackets, it means that this is a set having an element phi, right? This 0 is an integer, but 0 is an integer. Okay, so there is a difference as well as a relationship between these 4 things, right? G. Next is, first of all, write one result, that is A minus B. If we are having with A minus B, then A minus B can be written as A intersection B complement. Okay, this is the result. A minus B equals to A intersection B complement. We can prove this result also. How it can be? Left hand side is A minus B. According to the definition of difference of two sets, it means that this set is having elements such that x belongs to A and x does not belongs to B. This is the definition of difference of two sets. Now this is equals to x such that x belongs to A. If x does not belongs to B, it means that x will belongs to its complement. I hope that you all know the definition of complement of a set. Complement of a set means if the element is in the set, then it will not belongs to its complement. If the element is in complement, it will not be in the set. So x such that x belongs to A and है, in the place of and we have write this intersection and साथ में क्या आ गया B complement. So यही था right hand side A intersection B complement. So remember this result that A minus B equals to A intersection B complement. After that, we are having our next portion. Write down, let A, B and C be three sets. Let A, B and C be three sets. Then show that A minus B minus C equals to A minus B union C. Then prove that A minus B minus C equals to A minus B union C. Consider left hand side. This is A minus B minus C. We have done that A minus B can be written as A intersection B complement. Okay? We can apply the same result. A minus B. This is one set. This is second set. Whatever inside the bracket, we will consider only one. Okay? Whether it will be having 2, 3, 4, 5 or 10 sets, but this is in the bracket, we will consider one. So A minus B. A minus B can be written as first set as it is. In the place of minus sign, we will use intersection, and second set, we will take the complement of second set. Okay? Whenever we are having A minus B, we can write A intersection B complement, or if we are having A intersection B complement, we can write A minus B. Okay? Both ways implies है ये. So again, now we are having again A minus B. A minus B can be written as A intersection B complement intersection C complement, because of this reason. You have to write the reasons also. I told you last time. This is A intersection B complement intersection C complement. It will be A intersection B complement intersection C complement. Why? Because of associative law. We had done associative law last time. This is equals to A intersection. Now B complement intersection C complement can be written as B union C the whole complement. De Morgan's law. Remember this result? De Morgan's law. Now again, compare this with this right hand side. A, this is intersection, this intersection, and the complement of second set. Complement of second set. It can be written as A minus B. A intersection की जगह पे minus and second set, that is B union C, which is equals to right hand side. So this is equals to right hand side. Next question is show that A minus B minus C, left hand side is same. Show that A minus B minus C equals to A minus C minus B. A minus C minus B. Again, take left hand side. This is A minus B minus C. Using this result, we can write A minus B intersection C complement. Again, using this result, we can write A minus B as A intersection B complement. According to the associative law, we can merge these two terms. This is A intersection B complement intersection C complement. Now see beta, we need A minus C minus B. Okay, we need A minus C. First of all, we want to change the place of C. It can be C complement intersection B complement. This is because of commutative law. Commutative law, that is A intersection B equals to B intersection A, according to this law. This is equals to A intersection C complement intersection B complement. This is again because of associative law. This is because of associative law. Now, A intersection C complement intersection B complement can be written as minus B, and A intersection C complement can be written as A minus C minus B, which is equals to right hand side. We are using A minus B equals to A intersection B complement, which is equals to right hand side. Now, one question is for your homework. Show that A minus B minus C equals to A minus C minus B minus C. ठीक है? Next question is prove that A minus B intersection B equals to 5. Prove that A minus B intersection B equals to 5. Again, consider left hand side. A minus B intersection B. So, first of all, A minus B can be written as A intersection B complement. We are using the result A minus B equals to A intersection B complement. Okay? After that, this is equals to A intersection B complement intersection B. Which law we are using? Associative law. This is because of associative law. This is equals to A intersection. Now, the intersection of the set and its complement. The elements present in the set are not in its complement. The elements present in the complement are not in its set. So nothing is common between these two. So its intersection will be 5. We are using complement law. Okay. After that, the intersection of the set was 5. Nothing is common again in these two. So it will be 5, which is equals to right hand side. Okay. A minus B intersection B. This is equals to 5. Next is prove that A union B minus A equals to A union B. A union B minus A equals to A union B. Again, consider left hand side. Left hand side is equals to A union B minus A. So it will be A union. First of all, B minus A can be written as A intersection B intersection A complement. Again, we are using the result A minus B equals to A intersection B complement. After that, now see here we are having universal, here we are having intersection. So whenever these two signs are opposite, we will open the brackets A union B After that, this intersection will come outside. It will be A intersection, A union, A complement, because we are having union with it. This is A union, A complement. Which law is this? This is distributive law. Distributive law. So it will be A union B intersection. A union A complement. This is universal set. This is the set A. Outside the set is A complement. We are taking union. Union means either the element belongs to set A or the element belongs to A complement. So A union A complement will be universal set. It will be universal set. So we are to take the intersection of these two. This is universal set and this is A union B. So what will be common between these two? Common between these two will be A union B. Intersection means the elements which are present in both the sets, that is A union B as well as universal set. So it will be A union B, which is equals to the right hand side. Okay? So many questions like this can be in the MSTs or exams. So be prepared, beta. Next is we are having partition of sets. Next definition is partition of sets. Next definition is partition of sets. Write down the definition. Let S be any non-empty set. Let S be any non-empty set. A partition of S is a collection AI is a collection AI of non-empty subsets of S such that number one, AI intersection AJ equals to 5 for every I not equals to J, for every I not equals to J, and number two, union of I varies from 1 to n, AI equals to the set S. Union of all the small subsets जो हमने ये लिए थे, it will be equals to the set S. So what does partition mean? Suppose we are having this set, ठीक है? We have divided this set into some small subsets, ठीक है? Now these two conditions if hold, then we will say that this is a partition of the set S. For example, let us suppose that we are having a set U equals to 1, 2, 3, 4, 5. Okay? Let us take some small subsets A1. Let it be 1, 2, A2, let it be 3, and A3, let it be 4, 5. So we have to satisfy these two conditions. First condition is AI intersection AJ equals to 5 for I not equals to J. What does this mean? That A1 intersection A2, A2 intersection A3, and A3 intersection A1. We are having these three sets. So intersection of every set with other set. A1 intersection A2. Is there any common? Nothing is common. It will be 5. A2 intersection A3, nothing is common, it will be again equals to 5, and A3 intersection A1, this is again equals to 5. So first condition is satisfied for every subset. Second condition is if we take the union of all the sets A1, A2 and A3, if we take the union of these sets, it will be 1, 2, 3, 4 and 5. This is again equals to the set U. So if these two conditions are satisfied, then we will say that this U is a partition of the given set. Okay? Let us take one more example. Let us suppose we are having a set U equals to 1, 2, 3, 4, and 5. Let us suppose A1 is equals to 1, A2 is equals to 2 and 3, and A3 is equals to 5. Okay? So first of all, intersection of A1, A2, this is 5 because nothing is common. Again, intersection of A2 and A3, this is again equals to 5 because nothing is common. Intersection of A3 and A1, this is again equals to 5 because nothing is common. First condition is satisfied. But if we take the union of all these sets, A1, union A2, union A3, it will be 1, 2, 3 and 5. Is this equals to this set U? No, this is not equals to the set U. So this is not a partition of the given set. Let us take one more example. Let us suppose we are having the set U as, let it be same again. This is 1, 2, 3, 4, and 5. Let us suppose A1 is equals to 1, 2, A2 is equals to 2, 3, A3 is equals to 4, 5. Let us suppose we are having such subsets. So first of all, A1 intersection A2. A1 intersection A2 will be equals to A1 intersection A2. It will be equals to 2. A2 intersection A3, this is equals to 5. A3 intersection A1, this is again equals to 5. So first condition is not satisfied, that is intersection of these two sets is not equals to 5. Second condition, A1 union A2 union A3. This is equals to 1, 2. 2 is repeating. We will write only once. 1, 2, 3, 4, and 5. This is equals to universal set. Second condition is satisfied, but first condition is not satisfied. It means that this is not a partition of the given set. So what does partition means that if there are any subsets of the given set, first condition is intersection of every subset with other will be equals to 5. And second, if we take the union of all the subsets, then it will be equals to again the given set. So that forms a partition of the set. Otherwise, it will not be a partition of the set.